The universe that we see around us is real, but it's only one small facet of reality. The whole of reality consists of many such universes, and they're all equally real, and we call the whole set the multiverse. But if you want to explain how these physical events come about, there's no alternative but to postulate that what we see around us is not the whole of reality, that reality is much more varied and has a great multiplicity. This is an experiment, a very old one that's was first done hundreds of years ago. And there's one of them, just a single hole. And what would you expect to see? You'd expect to see, just if there's one hole, you'd expect to see one spot, but that's already not true. You see quite a complicated pattern. It's called an interference pattern. I'll tell you why. What would happen if we made a second hole? Well, here's another place on the screen where there are two holes. We get a completely different pattern. And through three holes, there's a different pattern again. That's the pattern we get from four holes. The place where it lands depends on what other holes there are. And what we must conclude from this is that something is coming through those other holes, and that process is interference.
What is this something?
Well, we can do further experiments to find out what that something is. All the other universes are as real as the one you and I are in now. You have to start thinking of yourself as not as an entity existing in one universe, but an entity existing in the multiverse as a whole. And so there are other copies of you and of me in other universes. Some of these copies are completely identical to us. Now, in those cases, it's really just a matter of words to say whether they are other universes or whether they're the same universe, if they're completely identical. There are other universes which are very like this one, but differ only in the position of one atom somewhere. Now, those universes are interfering with ours, and they are producing interference effects, which we could detect in the laboratory if we wanted to. And there are others which are very different, where the interference is so small that we will never see them, but they form part of the explanation of the things that we do see. So, you exist in multiple copies. I exist in multiple copies. And there are some universes in which I'm sitting here talking to you about something slightly different. And there are other universes where I've just got up and gone to have a cup of tea. If there are two identical twins called Joe and Jack, and Joe might ask, well, why am I Joe and him Jack? Well, the answer is, if you were Jack and he was Joe, you'd still be asking this question. The thing is, the fact of the matter is, there are two of you, and they are identical, or they were identical, until they started to become different by having different things happen to them. And it's the same with you and your counterparts in other universes. They start off identical. When they're identical, it doesn't make any difference whether you call them one copy of you or several. But then when they start becoming different, it is worth calling them different versions of you, slightly different versions. Some of them, in more distant parts of the multiverse, will be so different from you that it isn't worth calling them you anymore. We have to get used to the fact that new advances in science get further and further away from common sense. The fact that we can't directly detect parallel universes is to some degree an accident of the way we're built. So saying that you don't feel other universes is like the Inquisition saying to Galileo that they don't feel the earth moving beneath their feet. We don't understand it fully yet, and I don't think one ever understands a theory fully until one has its successor. And then we will understand the full implications and where it went wrong. And I would expect, again, on the basis of what usually happens in science, we would expect that future theory to be even stranger